Hey guys, what's up? My name is Gabe and this is Games with Gabe. If you recall in the last tutorial, what we did was we began to go over functions in Python. And so I explained what a function is and how to use a function. And then I tasked you with the problem of implementing the sine function and estimation of the sine function in Python. And so I have it coded right here and I'm going to go through and recode it with you just so that you understand what I'm doing. And if we pull up that Wikipedia article one more time, it looked like this. And they had the Taylor series right here. Wait, right here. Okay, and I told you to implement it up to x to the 11. So there's a couple ways that you could have gone about doing this. And I will show you the way that I came up with doing this. And then you'll notice we also have these things down here. These are factorial. So 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2, so on and so forth. And so I actually did a function for factorial, which made it easier to use this sine function. So the first function I did was factorial. And so I said factorial of x, and I initialize a result to 1. And then I say for I in range x to 0. So, you know, if x was 10, it would be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Then I just say result is result times I, which means we just multiply it by every single one of those numbers, and then we return that result. So if I were to print out the factorial of 3, we should get 3 times 2 times 1, which is 6. And we see that we get 6 printed down here. And then if I do 4, then this should be 24. And if I do 0, this should be 1. And so we see that all of that is correct, which is great. So that's the factorial function done, which makes it a little easier to code the sine function, which said it was a little bit tricky because you have this whole minus plus thing. And so this kind of complicates things. And you also have the power function. So x to the third plus x to the fifth, which you could also implement, but Python does provide a operator for that, which makes it a little bit easier. So what I did was I initialized result to 0 and then odd number to 1. And the reason I have odd number there is because you notice it goes up. It starts at 1, which is x to the first, 3, x to the third, 3, x to the fifth, 5. And so you notice that goes in this pattern 1, 3, 5, 7, 9, 11. It's going up by odd numbers. So I have this odd number that every iteration of the loop that I have in here, I increment odd number by 2, so it goes 1, 3, 5, 7, 9, 11, so on and so forth. Then what I do is you notice that it also has this minus, plus, where if you're on an even number, so this is the 0th iteration, then it's a plus, so 0, 2, 4, these would all be pluses. And then if you're on an odd 1, then it's a minus, so 1, 3, 5, so on and so forth. And so then if we go back to here, I have it say if I mod 2 equals 0, if it's even, if we're on one of those even numbers, then the result is result plus. So we're saying it's going to be a plus because we have the plus sign there. Then we want x to the fifth over x factorial. And so I do exactly that. I say x to the power of the odd number that we're on over factorial of the odd number that we're on. And then I say otherwise it's an odd number, so we do result equals result minus, so on. And so I have pi in here, and I say print sine of pi. And if we run this, you see it's very close to 0, which is good because this is just an approximation. If we increase this to, say, 10, it gets an even closer approximation. You see this is times 10 to the minus 10, so it's very close. And then if we do this over 2, we should get something very close to 1. And it just rounds it off to 1 exactly. So it's so accurate that Python just ends up rounding it to 1. So this is how you would do that function. And before we continue with more Python sort of things, I want to just introduce a little bit more work with these functions just so that you really understand how they work. The next function that we'll be exploring is going to be doing something with comparing two strings to determine whether they're the same or not. So like say you have the word apple and you want to check and see, is that equal to the word dog? Clearly we can say those are not the same. They are completely different. But in programming, you have to be very explicit. Why are they not the same? Well, we know they're not the same because if you look at this letter and this letter, which is the first letter of each word, they're different. Okay, well, what about apple? Does it equal act? Well, no, we know that's not true, but the first letter is the same. You might say, well, we know that the second letter is different. Okay, well, what about apartment? And you could go on and go forth until eventually you come to the conclusion to determine whether two words are the same. Every single letter in each word must be the same as the letter in the other word at the same position, the same index. And so this introduces the concept of something that we really haven't talked about, which is how do you store something big like this, a word? How do you compare each individual component? Well, Python has this handy thing called a list. And so all a list is a list of items. So instead of saying we have one number, like the number 10, we would have a letter here, A, P, P, L, E. That's the word apple. This is our list. And so then we could say, well, what's the list at position 2? And then you would return whatever the letter is at the second position inside this list. And one thing about programming is lists do not start at 1. This is not the first letter. This is actually letter 0. So if you've seen Kung Fu Panda, there is a level 0, and that's A. Okay? So lists always start with 0 as being the first index, and then 1, 2, 3, 4, so on and so forth. So if we said, what's the third letter, we would go 0, 1, 2, 3. That is L. And so Python, you can actually do something very similar to that. You could go, okay, so if I have the string apple, and it's stored in something called str for string, then you could say what is str3, and then that would print out 1, 2, 3, 4, so 0, 1, 2, 3, which is L, and it would say, well, that's the letter L, and it would give you that. And so then we have a very handy way of determining whether two words are the same because we can now compare two different things. Let's go a little bit more with these lists real quick. What else can you do with them? What if you want to add a letter? So you have apple, and you want to append the letter 0 to it. And I say letter because this is a character, not a number that we're adding to this. You could say, well, apple is stored in this variable called string equals apple. And then you could say string dot append, which will add it to the end of it. And then you would do a quotation, quotation 0. And this should add it to the end of this list, which is the apple. You can also explicitly create string as a list. So implicitly, this is a string. This is not a list, but implicitly, it's a list, actually. It's not a string. Explicitly, it is a string because that's what we see. If you want to declare it as a list explicitly, then you could say string equals, and then you would say A, comma, B, or P, pretend that's a P, comma, P, comma, L, comma, E, and then close square bracket. And so what this is telling Python, you want to store this as a list for sure. This is the type of list, and then you can actually add in numbers to this. You can add in other things too. And so this is an explicit list. This is sort of an implicit list. Python stores it as a list that you can do things like indexing, which is where you have this string 3 thing where you can sort of pick the letter. And we call that indexing. So if you ever want to index into a string, you do the square brackets like we did right here. And then you say a number, and that's the index of that list that you want to access. And then same thing here, this would be 0, 1, 2, 3. And then you can also store numbers inside a list. So you could say num equals 1, 2, 3, 4, and then num 0 would be, and you do the square bracket, number, square bracket, would be 1 because that's the first element inside this list, which is the 0th index. Okay, so these are lists. We can play around with these. I'll play around with them a little bit more on screen so that we can see them. And what we're going to do to practice with functions a little bit more is we're going to create a string compare, which compares two strings determines whether they're the same, and then returns true if they are equal, false otherwise. Okay, so let's get to it. While I'm experimenting with Python, I like to open up this idle shell. Remember, we used it at the beginning. You can just type in idle, idle in your search bar, and it opens it up. I like to use this because it's very nice and simple to sort of experiment with different concepts and stuff and see how they work. So like I was saying earlier, we could define something called string, and then we could say equals apple, okay? And if we say, what is string 0? It says it's A. What if we say string 3, which if you remember we said should be L, and it prints L. And then you can do something really cool with this too in Python. Remember how we did for loops, where you can say for I in range 10, and it sort of goes through 0, 1, 2, 3, 4, 5, all the way up to 10. Well, you can do the same thing with lists. You can say for item in my string, print that item, and then what do you expect this to do real quick? Well, what it's going to do is it's going to go through this list and print out each item as it goes through, which would be A, P, P, L, E. And then sure enough, we see it print out every single letter. This is really cool because it's nice, simple, allows us to do several cool things with it. Think sorting things by alphabetical order, different things like that. You can do it very easily by looping through each letter inside of those strings. And then we can also declare it like this. So if we say string equals A, P, P, L, E, and then we say string 0. Once again, it is A. String 3, it's L. And if we say string dot append, we'll do the letter 0. And then if we say string, then it'll print out what that is. And then you notice there is a 0 at the end of this. And I don't think you can see my cursor. Okay, so these are really cool. Let's see how we can use these lists to our advantage to determine whether two strings are the same. And then as always, you can look up Python's documentation because these things have a lot of other cool functions, which we just learned about, which you can access by doing this dot. So you can say like dot append, and then you can also say something like, oh, and see Python even tells you what all these are. So you can even say something like dot pop. And what does that do? Well, it just gave us 0. If we look at it, the 0 is gone. So there's all these different functions. We will go into more depth into these in a future tutorial. For now, let's practice with functions and see if we can compare two different strings. Okay, we want a function that compares two strings. So we'll say define compare strings. String 1, string 2. Right now, we'll say pass. We don't want it to do anything yet because we're just thinking about how this thing works. And then what we want to do is we want to be able to say print compare strings, a string, or actually we'll do our example, apple, dog, and we want that to say false because those are not the same strings. So let's go up into here and say how do we compare these? Well, we said if we go through letter by letter in each string, and if they're not the same in the same position, then we know it's not the same. It's not equal. They're not the same. So we need to say, well, let's start off going through for each letter in string 1. We want to check if it's the same as that letter in string 2. Well, which position is it at? Oh, we need something to keep track of what position we're at. So we'll say I equals 0 because we'll be at the first letter at the beginning of this. And then we'll say I is assigned I plus 1. So every time we go through a letter, we increment I by 1. This way we know which letter we are at inside this string. If we're at A, P, L, E, and this will keep track. It's a 0, 1, 2, 3, 4. And so let's just print the letter. And then we will also print, we'll print this. We'll say print letter at I equals, and then stri. And then we'll say, and this should actually be a plus. And then we'll say plus is, and then we'll say plus letter. And this should print what the letter is, okay? So, and this will give us string 1. So let's see what happens when we run this. Letter I equals 0 is A, 1 is P, 2 is P, 3 is L, 4 is E, which is great. It's exactly what we'd expect it. Okay, what about, we could say what is the letter at I position in string 1 now. So instead of doing the letter will say string 2, index I, and then we get letter I is 0 is D, 1 is O, 2 is G, and then we get an error, and it says string indexed out of range. Okay, so this is great because it works, but what's happening is it's saying, okay, so this is working, but then we're running into a problem because apple is a different length than dog. What if we say what is dog at index 3? Well, that's the 4th letter. Well, dog is only 3 letters. So Python is basically telling us, hey, there's no way to tell what the heck that is. And so it's just saying there's an error. So let's do this. We need a check first. We'll say if I is less than, we can get the length of a string by typing len for length of string 2. Then we'll print the letter. So let's try this one more time. And we should get no errors this time. We run that. Okay, sweet. And so it goes through. There's no errors because we make sure that it's in the right position. Like we make sure we're not going to get something that's out of bounds of this string before we try and print it. Okay, so now we know we can get this letter and we can check this letter. So what do we want to do? If those 2 letters are not the same, then they're clearly not the same string. So we'll just say if letter does not equal string 2 at index I, then it's simple. It's false. We return false. We say, just stop everything you're doing right now, return false. These 2 strings are not the same. So this will just jump out of here, come to here immediately until it is false. What if we make it through? What if we go through every single letter in string 1 and every single letter in string 2 and they are all the same? Well, then clearly they're the same string, right? We return true. This is actually not true too. We'll see that in just a minute. But let's see what happens. So if it gets through here, then we stop immediately from here. We return true, and it's all good. And so basically, if you have a return in the middle of something that you're doing like this, it just stops everything it's doing. It jumps all the way out of this function and just goes back to here immediately. So let's see what happens when we run this. It says false because these are not the same words, right? Let's try apartment because those have some letters in common, but not all letters in common, right? So we do this again. It says false. That's sweet because letter 3 is different. Let's try apple. This should return true. And hey, we get true. That's awesome. But what about apple tree? What's going to happen now? We still get tree. Why? Or we still get true. Why is that? These are 2 different words, but we're still getting true. And that's because we're looping through every single letter in the first string. And then we say, if the letter is not equal to the string 2's letters, well, these are all the same up until this point. It's when they're different, but there's no more letters to check in the first string. So then it says, oh, I think they're all the same. It must be true. But it's not because they're different lengths. So then what we can have down here is, okay, if they all made it through fine and it's exactly the same, and we can actually do this up here instead of checking all of them, we can just say, if the length of string 1 does not equal the length of string 2, then return false. Because if they're not the same length, there's no way they can be the same string. And so if we run this, now it says false, which is the correct answer. And then if we take this out, make this apple against apple again, it says true. So here we've just done a simple compare strings function, which checks 2 strings to see if they are the same at each letter in each part of the word, and then it returns false if they are not. And we also learned about this thing called a list. What is a list? Well, a list is something that you can use in Python to store collections of objects, collections of integers, collections of strings, collections of truth values. And this is useful in case you need to do something like this, where you're checking each indexed position. And then also indices start indices, not indexes. So indices start at 0, and then they go 0, 1, 2, 3, whereas we would normally count at the first letter. It's the 0th letter in programming. So these are sort of the fundamental things we've learned about. Let's get a practice problem real quick that I'm going to assign to you to try and do yourself that kind of uses all these concepts and see if you can get it done. The problem I'm going to give you guys is something that I just made up myself. And so this is basically, say you have you have a list or a string of characters. So like some big list, it could be multiple words, a list of strings. And what I want you guys to do is write a function that counts the number of letters in the string. And so what it should return is, if I say count A, then it should tell me how many A's are inside of this string that is passed in. So if I say count A, and then the second parameter would be the string that I'm passing in, then it will count how many A's are inside of this string. And if I say count how many B's are inside this string, it will return how many B's are in the string, so on and so forth. And so just give that a go. Try and write a function called count that counts the number of letters inside of a string, because then we can do some cool little charts and stuff in the future, counting the occurrence, how many times letters occur in books and everything too, which we will be going over in the next tutorial. So give this a go, see if you guys can get this done, and then I will give you the solution in the next video. Thanks for watching. If you guys like this, please hit like and subscribe, and I will see you next time. Thanks.